Hello, this is Derek again. I'm in the workshop and just wanted to put together a little video on old school ignition systems. This is all probably before 1980s. Cars, motorbikes, all very similar. Now we're not talking magnetos. That was earlier than that. This is coil and points ignition. Nearly everything was coil and points ignition. People get a little bit confused, not because it's complicated, because it's not familiar with modern electrics on cars. They're all computerized and they have electronic ignition. This is before electronics, before computers. So this is the ignition coil and a point system using a cam and a condenser. All that's gone now. So basically what you've got is, what I've got here is I've lashed this up on the bench so you can bench test something, and it's just testing, it's just showing you the layout and how it works. So basically you've got an HT coil. Now this is off one of my bikes, 6 volts, got a 6 volt battery. Now this could be on the cars and on the old bikes, they look like a can with the HT coming out the top. It's exactly the same, 2 wires on, 2 wires, one from power in and one from power out, and the HT coming out this side. Now on this one I've got the HT lead going down to this. It's just wired in series. The HT lead continues and goes into this strobe and out of the strobe into the spark plug. The spark plug fires. So every time the spark plug fires on this, to show you, that will flash red. It's used to time engines up, but you can actually just see whether it's sparking or not. And if I don't use that, you won't be able to see the spark on the plug, it's too light in here. So basically it's wired up. The condensers, you've got a condenser, got the points, got the cam, got a battery and a coil, and that's it. That's the whole system, and from that it should run. So what you're looking at is I'm using a negative earth, so I've got a positive lead coming down from the battery. This will connect up to that wire there, and if this was in a car or a bike or something, you'd have a switch across here. So you'd be a switch it on or switch it off. So when that's plugged in, it's switched on. So you've got the main positive into the coil, then the supply comes out of the coil, and on this one it goes into a green wire and then a white wire, and then it comes down this brown wire to the points. Now this points connection here is insulated. It's very important that this wire is not in any way connected to this base plate. It's got to be completely insulated. If it's not insulated, this supply goes down to earth and it just won't work. So it's important that fibre washer's there, that fibre washer's there, and there's a little plastic washer on the inside as well. And so it's got to be completely insulated. Another thing you've got to kind of make sure is the points, these 2 points here. Let's get a screwdriver. These contacts here are clean, but when that shuts like that, it makes a contact across those points. Now they can get a carbon build-up on there, like a spark. As it arcs across, it creates like a bit of a fouling kind of carbon build-up, and that can affect the points closing. Oh, there's oil in there. They need to be really nice and clean, and make sure that the pivots around this pivot here, it's nice and springy, it's not lazy, because when they've been left for a long time, they do go rusty or get a bit of dirt on them. So you've got to make sure that's nice and springy like that. It's not lazy, you don't have to push it. When you let it go, it snaps shut like that. If that becomes lazy, you get a bad connection there and it'll give you a fault. Now on this I've got, because my spark plug's not screwed into the engine and this base plate's not screwed to the engine, I've got an earth lead that comes from here, from the base plate to the base of the condenser, from the condenser to battery negative, which is earth. And I've got a wire coming from the spark plug to earth, because the spark plug needs to be earthed as well. So basically that's how it's set up when it's in a bike or a car. Now what happens is, as this rotates, this is a cam, it's got a little lump on one side, and as it rotates it opens up points like that. I can see the points opening there. Every time that contact is broken, it should flash. The spark plug should spark and that should flash. That means that it's sparking. What happens is, you've got a supply down to the coil, which in this case is 6 volts. There's 2 coils inside of it, a primary and a secondary. The supply goes into the coil, it goes round the primary coil first, then it goes through the secondary coil, and then comes out of that green wire, ends up going down to the points connection. What happens is, when the points are closed, there's a circuit that completes a circuit from the positive through the coil, through the points, down to earth. What that does, it creates a magnetic field inside of this coil, and when you open the points, when the points are opened, the circuit's broken, the magnetic field collapses, that magnetic field collapses and it creates an induced high voltage surge down the HT lead to the spark plug. Spark plug goes to earth and it sparks. Now the condenser is there. There's a lot of myths regarding condensers. People say it gives this spark plug an increased voltage, but it doesn't. The condenser has 2 functions. The primary function of the condenser is to speed up the collapsing magnetic field, because as them points open, although it appears to be very fast, it is in actual fact quite slow. So as the points are opening, the arc, get an arc across the points, because it's not kind of instant. And when you get an arc across that point, it's too slow. So the condenser, when it gets easier to charge the condenser than to arc across, it charges the condenser, and it takes the voltage away from this coil a lot faster than it would do just by opening the points. So this coil, the magnetic field in the coil collapses a lot faster. The faster it can collapse, the better the voltage going down, the induction voltage to the spark plug. So that was the primary reason for the condenser. As a consequence of doing that, they found that because it doesn't spark as much, because the current is being taken to the condenser, it protects the points as well. So if you're suffering from something where it keeps burning points up, the condenser's probably not working. Having said that, a lot of people, the first go-to kind of symptom when something won't start or you're not getting a spark is it's the condenser. In my experience, it's very rarely the condenser. These are very, very reliable. Very rarely go down. It can go down, it's very rarely go down. I've had these that's 50 years old, still working fine. If you have one that's not sparking, most likely problem is going to be the points are dirty, or this is lazy. it's stuck open, or they've actually stuck closed, they're not opening because that's worn down there, that little arm there that rides along the cam, that could be worn, the points are shut and they never open. As you turn that, instead of that happening, because that's worn there, the points don't open. That gap needs to be around between 12 and 15 thou when they're fully open. You have to bear in mind that when you adjust the points and you do anything around it, it could affect the timing. Now the timing is adjusted on cars by rotating the distributor, which is on top of here. You rotate it to either advance or retard it. On some of the bikes you can actually slacken all the base plate off here and rotate the base plate to a different position, so you can get the timing spot on. But we're not talking about timing on this video, we're just talking about how this system works. There's a little felt pad there. This felt pad, because I've only lashed this up, this is not like a simulation of anything, it's just a set of points screwed onto a piece of wood. That pad would run against this cam. You put a little tiny bit of oil on it and it lubricates the cam to prevent that that fibre arm from wearing. So there you go, it's you've got the positive down to your coil. When it's switched on, the supply goes through the coil, through the primary, through the secondary coils. It goes via that brown wire to the points. When the points are closed, the supply goes to earth and the coil is energized. When the points open, the supply is broken, the magnetic field in the coil collapses and you get a spark. So let's try it. So it's now switched on. So every time I rotate this cam, the points are closed. Sorry, the points are open. Points are closed. Goes down. All I'm doing there is rocking the points open and shut. Every time the points open, you get a spark there. It's actually sparking here, but you can't see it because it's too bright. But that's how the system works. So it's very, very simple. It's very simple, and that's why it's all been changed to electronics, because there's a lot of places this can fail. Something that's not sparking, like I said, it's usually down to a bad connection on the ignition switch, would be that connection. Very, very common, one of these insulators is missing because somebody's been tinkering about. They took the points out to clean them, they've left an insulation washer out, so this wire is going down to earth all the time. If that's why it's going down to earth all the time, it's never going to, you're never going to get a field in the magnetic coil, never going to get a magnetic field building up in the coil. So that's a likely spot for a fault. Likely spot is this being tight, not being springy enough, and very common, either the cam's worn so the points are not opening because it's worn there, or these are dirty. You've got oil or something inside of there. Now the condenser, what happens is, when the points open, the supply goes from here, instead of going across there to earth, it's easier for the supply to charge the condenser up. So as the points, just as the millisecond, that point start to open, when it's easier for this supply to go to the condenser, it will charge this condenser up, and then it takes the current away from the points, stops them barking. When the points close, the condenser discharges itself to earth, so that when the points are closed, that's dead, not doing anything. So this kind of fallacy that the condenser gives the spark plug a boost is wrong. It doesn't do that. All it does is protects the points, and it speeds up the collapsing magnetic field in the coil. So basically that's it. That's the whole thing as it works. But like I said, you're talking here of old school, before electronic ignition, before computers, sensors and things like that. This is all the old system. Works very well. Okay, just thought I'd share that with anybody. If it makes sense. I don't make money out of my channel. I'm not bothered if anybody subscribes or anything like that. It doesn't make any difference to me. Okay, bye.